to use. And you have in front of you a Venn diagram. Jose? Is there anyone who wants me to explain how a Venn diagram works? No. Okay. So in a few minutes we'll label the top so you'll know what we're talking about. If you look at our target for today, look up at the board at the target. You will probably be able to guess what's going to go at the top. So look at the target. What should you be able to do by the time you leave today? Okay. Covalent, yeah. Right. Awesome.
Great. Now you guys know that last week what we did was we did ionic bonds, right? And the week before that, we combined different atoms. Remember the love stories? Yeah. Today something very different is going to come your way, all right? And so, has anybody not worked with a Venn diagram like this with two circles? Okay, so you kind of know how they work? All right.
What goes in the middle section of the Venn diagram? The same. So whatever is the same between the two things that you're talking about goes in the middle. And what goes on the outside?
What's different? The stuff that is different.
Right, and you put, how it is in one under that circle and how it is in the other. Great, so you know how the Venn diagram works.
Okay. So the first thing we probably want to do is we want to label each of those circles, right?
So on the left-hand side, how about if you write ionic bonds?
And
on the right-hand side, covalent bonds, maybe.
And we'll kind of show you what that looks like. We're going to show you.
I like your apple.
Thanks.
And you guys, I'll tell you what's coming today. What you're going to do is, actually, Mitchell LeCompte is going to show you a brand new story today. Only you're not going to create the story on your paper, okay? He's going to create a new story, but it's going to look probably different than what you're used to seeing, because we're going to do a different kind of bond today. I've already explained that. Okay? So you should be labeling each of your circles like you see on the overhead there. So ionic bonds and covalent bonds.
Okay, so this is what we know, and this is what we're going to find out about today.
Yep.
And as we do it, you'll pick up similarities and differences. So I'll give you a minute to finish writing that.
So just to review, you guys, what goes in the middle part here?
What they have in common.
Yeah, the things that are the same, right? Things that are the same go in the middle, and we're going to do that part first, just so you know. Okay, so we're going to put stuff in this box or this section first. Things that are the same. Now you know all about these ionic bonds because you studied those last week. Here's the new part right over here that we're going to look at today.
Okay.
Notice that there's like 1, 2, 3, 4, 5, 6 lines. Don't let that limit you. You may find a lot more things to put in there than just 6 things, okay?
All right.
Here comes the story. Here's what I want you to do first. Just relax, sit back, and watch the story. But be thinking about what kinds of things are the same between what you know from last week and what's happening this week. And if you want to take out a story from your folder from last week, I would recommend that, because then you can look at your story and go, oh yeah, that's the same. Oh wait, that's different. You can be thinking about that now. So if you're wise, you will take out your stories from last week, or at least one of them, so you have it in front of you, okay? All right.
Okay, so if we start our story, you're just going to listen. You're not going to write this down. We start our story with Louis Goss, dots for phosphorus. Phosphorus has 5 valence electrons. And chlorine. Chlorine has 7 valence electrons. I'm going to go to my next square, and in covalent bonds, I have to tell you either the chemical formula.
Maybe drop it a little bit.
Okay,
Yeah, there we go.
or the name, because in covalent compounds you can make more than one compound from the same two elements. So in this one, I'm going to tell you that the formula is PCl3. Now, the name that goes for PCl3 is phosphorus trichloride. Now I'm going to go down to my third box. This box is where we show the sharing of electrons. So I now know that there's 1 phosphorus and 3 chlorines. So here's my phosphorus. It has 1, 2, 3, 4, 5 valence electrons. Every place where there's only a single valence electron, not a pair, that's a place where I will, it's like a bonding site, it's a place where I will share an electron. So one of the chlorines comes up, it has 1, 2, 3, 4, 5, 6, 7 valence electrons. The phosphorus and the chlorine are going to share those 2 electrons. That is sharing electrons. The other chlorine comes up here. 1, 2, 3, 4, 5, 6, there's 7. That's a sharing of electrons. When they're sharing, now this chlorine has 1, 2, 3, 4, 5, 6, 7, 8. This chlorine has 1, 2, 3, 4, 5, 6, 7, 8. So that's at stable 8, like a noble gas. The phosphorus right now has 1, 2, 3, 4, 5, 6, 7. So the third chlorine comes up here. It shares its single electron over here with the phosphorus. There's 1, 2, 3, 4, 5, 6 more. So now the chlorine, this last chlorine has 1, 2, 3, 4, 5, 6, 7, 8. The phosphorus now has 1, 2, 3, 4, 5, 6, 7, 8. Everybody has 8. Everybody looks like a noble gas. They're stable. They've shared their electrons. In the last box, we're going to write the covalent bonded molecule. Here's the P. There are the 2 electrons that we had right there that weren't in a bond. Now, instead of showing the sharing like this, I'm going to draw a straight line. Here's one of my chlorines. This straight line stands for a single covalent bond. Down here is a straight line. I hope you're following the story. Here's a straight line. Those are all single covalent bonds. And there's what my molecule looks like at the end. This is a covalent bonded molecule. End of story.
Okay. Now, on your Venn diagram, just in the middle part, here's all you're going to do. You're going to take about 2 or 3 minutes and just write down everything about this type of bond that is the same as the bond you did last week on ionic bonds. Now, one of the first things that I would list, I'm going to give this away. you can put this in the middle, is they both have Lewis dots, don't they? Absolutely. So you could say they both have Lewis dots. Now from there, you're on your own. See if you can find some more things that are the same. And remember, put them in the middle circle, okay? Right on. That's exactly where you want them. Okay. Okay, I think we'll sit the camera down for just a minute and let them work, and then we'll pick it up and see what everybody has. So if you want to scrub ahead, who's ever watching this, you can scrub ahead. Okay. Excellent. Yeah. You know, I think I'll come around and see what people. We'll look and see what they're putting, but I won't show their faces, so they won't know that. Okay, that one has Lewis dots, because they both have Lewis dots. Okay. And this one says, yeah, thanks for showing. Oh yeah, that's cool. Have that, see if I can focus. It doesn't focus very well, does it? Tap, that'll work. There we go. They both have valence electrons. Yep. Okay. Thanks for showing that. Is there anything new over here? Okay. Very. Here's another one that has valence electrons. Let's get in here and take a picture of that. Yep. Those are the same. Well, I wouldn't do that because they don't both have ions. Okay, so you want to get rid of the ions. Okay. But
Are you recording this?
But I like. Well, I'm recording your paper. But they both have formula, and that's good. You want that. That's an excellent answer. Because they both use formulas. Good. Oops. Now I'm going to draw a stick, and it's going to be island number 6 today. Are going to share first, and person number 4. So that looks like Shayla. I'm not going to film you, Shayla. So, so what's the same? Go ahead, Shayla.
They both have valence electrons.
They both have valence electrons. Okay. That's true. They both use valence electrons. And what are valence electrons again? Outside electrons. Good. Okay. That's true. And do you have any more? Different, sames?
They both have Lewis dots.
They both have Lewis dots. Right on. They do. Okay. Anything else? Okay. What did you have? That's different. That's the same too that they didn't have. That you didn't have.
I have the same thing.
Oh, same thing? Okay. Does anybody else have anything else that's the same? Yeah, go ahead.
Movement,
Nate.
the movement of electrons.
Explain.
Yeah.
The one up. It's like the one that you did with the with all 3 of the ones and they like move them.
I didn't move them.
Yeah. They didn't actually leave
Yeah. they didn't
the
leave.
atom. Colton?
Yeah.
Then they bond.
Yes. They bond. And you guys can put that down too. That's something that's the same. They bond.